Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Okay, the 2012 complex number question was, the complex number z has modulus 5 and 1/16 and argument 4 pi over 9. Find in polar form the four complex fourth roots of z. That is, find the four roots of w for which w to the power of 4 is equal to z. Okay, so the wording was a bit difficult in this one. I suppose it was important to spot, just change colour. It was important to spot that they gave you the fact that or was equal to 5 and 1/16, and that they gave you the argument or the angle 4 pi over 9, okay? So therefore, z could be written as I'm just going to write w to the power of 4, which was equal to z, was equal to 5 and 1/16 cos of the angle plus I sine of the angle. Okay, that's how we write in polar form. Okay, or cos of the angle plus I sine of the angle. Okay, and they had them all worked out for us in this case. They had them given to us, so that part was fairly straightforward. Okay, then it asked you to find the roots of z, okay? So in other words, they want you to solve it for w. Find the four values of w. So if we're to find the four values of w, we need to take w to the power of 4 and we need to raise it to the power of a quarter, okay? Because we're playing with the rules of indices here, where 4 a power to a power, if we look at the rules of indices, we multiply them. 4 times a quarter is 4, okay? Or a quarter is 4 root, okay? Whichever way you want to look at that. So we need to then take 5 and 1/16 cos, I'm going to write it in general form here because you always need to write it in general form when you're doing roots, okay? And obviously they've given us our angle in radians. I know that because of the pi symbol. Anytime you see pi, that means the angle is in radians, which is why I'm not doing in 360. I must do the angle in radians for this case, okay? Because you couldn't have radians and degrees all in the one angle. Plus I sine 4 pi over 9 plus n 2 pi, close the bracket, and that will all have to be, if I'm going to rise this side to the power of a quarter, then of course I have to do the same for this one, okay? It's the same thing. So at this stage, I'm going to apply de Morvis theorem. And again, back to the log tables. So if I have a polar form complex number to the power of a quarter, what do? Well, I do or to that power, so or to the power of a quarter, and then it's a quarter times the angle. Okay, so that's what I'm going to do now. So that is equal to 5 and 1/16 to the power of a quarter, bracket, cos a quarter times 4 pi over 9 plus n 2 pi, plus I sine a quarter, bracket 4 pi over 9 plus n 2 pi. Okay, be careful how you put 5 and 1/16 into your calculator. Okay, make sure you hit shift and the fraction button. Okay, because sitting behind that, if you have a look, is a mixed number. Okay, it's expecting a whole number with the fraction beside it. Okay, so you need the 5 and 1/16 all to be written to a quarter. If you put it into the calculator like this, using the fraction button without the shift, okay, if you hit 5 and then the fraction button and you hit a quarter, then it could just be the 1/16 that's risen to the power of a quarter. Okay, now it does depend on how some calculators are programmed, but to be safer, it won't go wrong if you use that shift button to the power of a quarter. Okay, and I'm getting 3/2 when I put that into the calculator. Okay, so this whole thing here is giving me 3/2. So cos, now 1/4 times 4 pi over 9. Well, the 4 will cancel with the 4 there. So it'll be pi over 9 plus n pi over 2, or n a half pi, whichever way you want to write that, plus I sine pi over 9 plus n pi over 2. Okay, so we're all set up now. That's as simplified as I can get. I'm now going to find my 4 roots by letting n equal to 0, n equal to 1, n equal to 2, n equal to 3. Okay, so if it's to the power of 4, then there are 4 roots. So I'm going to just add a page, and I'm going to do it all on the next page rather than splitting across. So my first root is when n is equal to 0. So I'm going to get 3/2 cos pi over 9 plus I sine pi over 9. Okay, let me just check now that cos pi over 9. Okay, so n is 0, so this part disappeared. My next root, n is equal to 1, 3/2 cos of pi over 9 plus n is now 1, so I have to add on pi over 2 plus I sine pi over 9 plus pi over 2. Okay, so you need to tidy him up. 3/2 cos. So in my calculator, I am doing pi over 9 plus pi over 2, and I'm hoping, 11 pi over 18. I was going to say hoping I'm not going to get a decimal for it. So 11 pi over 18 or 11/18 pi, it's the same thing, plus I sine, and you don't need to do it twice because it's the same angle. Okay, why am I not changing these to rectangular form? Because it asked me to leave them in polar form. Okay, so if I needed to change them to rectangular form, I would multiply this in. Okay, and multiply this in. So n is equal to 2, gives me my second root. So 3/2 cos of pi over 9 plus 2 pi over 2, okay, or plus pi, plus I sine pi over 9 plus 2 pi over 2. So that is equal to 3/2 the cos of ten pi over 9 plus I sine 10 pi over 9. And then n is equal to 3 is my fourth root. So it'd be cos of pi over 9 plus 3 pi over 2 plus I sine pi over 9 plus 3 pi over 2. Okay, so let's just tidy it up. 3/2 cos of (29 pi over 18) plus I sine 29 pi over 18. Okay, and in my head I was just going 18 by 2 is 36, 29 is less than that 36, so it's less than 2 pi, so it's all good. Okay, so that's your 4 roots in polar form. So that was part A of that particular question. Part B then said, Z is marked on the Argand diagram. On the same diagram, show the 4 answers to part A. Right. So to plot them, we need to change them to rectangular form, okay? So the polar form is no good to us for plotting them, so actually we have to change them to polar form anyway. So I'm going to do it on the same page. I'm going to come over here and do them and then plot them. Okay, so how do I do them? Well, I'm changing my calculator to radians first. So that's it in radians. So then 3/2 cos pi over 9. Pi over 9. And I get 1.4095. I'm just going to leave it as one place of decimal because I have to plot it. And then I go back and change the cos, or the cos to sine, plus 0.5i. Okay, let's come over with this one. So it's 3/2. I have sine in the calculator, so I'm going to do that bit first. So 11 pi over 18. So I'm getting plus 1.4i here. Now that's because I had sine in my calculator. I'm just reusing the same stuff. So then cos, so I'm getting minus 0.5 plus 1.4i. Okay. The next one, 3/2, I have cos in my calculator here. So let's go 10 pi over 9. I'm getting minus 1.4 here, and then I'm going back to change cos to sine, and I'm getting minus 0.5i. And then this one, I have sine in the calculator, so I just need to change the angle to 29 pi over 18. So that's cos in my calculator, so 0.5. We go back and change him to sine. Minus 1.4i. Now, guys, I know these are right, okay? Well, I have a fair idea they're right because I've got the right pattern. So I'll tell you the pattern that I'm thinking about. Okay, so the first one I got is over here on quadrant 1. If you think about it, both the real and the imaginary is positive, so it's up here in this quadrant. This one, the real is negative, so I'm over here, but I'm up in quadrant 2. Okay, this one, both are negative, which brings me to quadrant 3. And this one, this is positive, but the I part is negative, so I'm in quadrant 4. Now, remember what we said in the last question when we were doing roots? Where were we here? We said that they were evenly spaced about a circle. Okay, so I would surely expect 4 roots to be 90 degrees apart. Okay, one in each quadrant. So these feel like they're right. Okay, and once you know that and you expect that pattern to come out as you're doing them, you have a fair old idea if you've put it into your calculator correctly. So 1.4 plus 0.5i. So 1.4 plus 0.5i is somewhere here. So we'll just call him W0, okay, because we were solving for W and that was when n is equal to 0. Okay, my other one, minus 0.5 plus 1.4. So minus 0.5 plus 1.4. Somewhere there. Let's call him W1. Go back and have a look. Minus 1.4 minus 0.5. So minus 1.4 somewhere here. Let's call him W2. And then W3, 0.5 minus, so 0.5 minus 1.4. So let's call him W3. Okay, so I hope you can see that. I'll draw the lines out from the origin. Okay, and if I manage to draw a circle, okay, so that's easy to draw a line. Can you see that? Can you see that they are 90 degrees apart? Now, not perfectly on mine because I'm on digital, but anyway. Okay, and if I could, let me undo that. If I could draw a circle, it'll let me. Can you see they all fit on the circumference of a circle? Okay, which is exactly what I expect with roots. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice? In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.